All right, we're going to continue with our discussion about probability rules. We're going to talk about two-way tables and probability. So we have a two-way table here. This is a two-way table of survey of males and females, asking them whether or not they had any pierced ears. And these are the responses by gender. And so we have a two-way table, and then now we can find the probability frequency or relative frequency a student has pierced ears. So we look in the table, student has pierced ears. It would be any of the students, so 103 out of 178. Student is a male with pierced ears, so 19 out of 178. I'm sorry, a male with pierced ears, 19 out of 103. Is a male or has pierced ears. Is 174 out of 178. So is a male, 90 of them, or has pierced ears. There's 84. You can just subtract 4 from 178 to get 174 out of 178. So here we're using a two-way table to interpret probabilities. Basically, they're relative frequencies, but we have to interpret also what is being asked. For example, when we ask or, it's either going to be male or yes, but then we have to consider double counting for 19 and take that back out. All right, so it would be just 90 plus 84. Okay, this brings us to homework 5.2.4. Right, so below is a table of results from students who took the AP Stats exam. The table shows a percent who received a given score of 1, 2, 3, 4, 5, and the probability basically that if you selected anyone at random, what score they would get. And so the question is this a legitimate probability model? Yes or no, and why? And then find the probability that a student scored 3 or better. So you can copy this down, and then I'm going to move on to our last topic of discussion. We're going to continue on with the two-way tables, but include Venn diagrams. So we're going to talk about Venn diagrams and probability. Before we do that, we need to talk about intersections and unions. So we'll talk about what a union is, and I like to relate the two roads Mary and Homestead. So the union of Homestead and Mary is going to be everything on Homestead and everything on Mary. So we're going to say that's or. So if I can find a point on Homestead or Mary, then any of these points in green will work. And so we're going to identify that with this U, or. The intersection of Homestead and Mary is just the location that is common to both. So if I choose a point that's not in here, it's not on Homestead and Mary. Only the intersection is a Homestead, is a point, or includes all the points that are common to both Homestead and Mary. And so we're going to use this upside down U to designate intersection, or we will use and, intersection, and relate the intersection where the events have to occur in both, or an event is in both A and B. All right, so let's talk about, let's move on to our Venn diagrams. I have now two circles. I have event A and event B, and then what's in the middle is going to be the intersection of the two. And then if I want to find the area of the combined figure, A and B, then what I need to do is I need to take the sum of the areas for A, or events, and B, and then I'm going to subtract the intersection because I've counted that twice. I have the entirety of A plus the entirety of B, and the entirety of A and B have included that intersection twice. So I need to subtract that out. So it's 1 plus 3 minus 2, and that's what I get here. The probability of A or B is equal to the probability of A plus the probability of B minus A and B. So a union includes outcomes from both events, even if they are different. And when we find the probability of A or B, it's A plus B minus A and B. And we can use the union and intersection, union for or, intersection for and. All right, so just rephrasing of the same statement, A or B is equal to A plus B minus A and B. The union of A and B is equal to A plus B minus the intersection of A and B. Right, so mutually exclusive events, we can still use this formula that you just learned, even with mutually exclusive events, because then the probability of A and B is equal to 0. Right? So then if the probability of A, and this goes back to our rule, right? If the events are mutually exclusive and this is 0, then the probability of A plus the probability of B is equal to the probability of A or B. So if two outcomes have no events in common, they are considered disjoint or mutually exclusive, and A and B, the probability is going to equal to 0. All right. All right, so now let's move on from the Venn diagrams. Let's give an example here. Of 30 people attending a beach party, 17 got sunburned and 25 people were bitten by mosquitoes. If everybody either got sunburned or were bitten by mosquitoes, how many people got both sunburned and were bitten? All right, so we're going to answer the question by drawing a Venn diagram, identifying the values that correspond to each portion of the equation, then determine the answer. All right, so I have A or B is equal to A plus B minus A and B. I have sunburned 17, bitten by mosquitoes 25. I know that A or B is equal to 30, which we defined. 30 is equal to 17 plus 25 minus then 12. So 12 is going to be A and B. So 12 people were both sunburned and bitten by mosquitoes. Not a very exciting beach event in that case for those people. All right, so this brings us to homework 5.2.5. Of 40 people attending a beach party, 19 got sunburned and 35 people were bitten by mosquitoes. If everybody either got sunburned and or were bitten by mosquitoes, how many people got both sunburned and were bitten? So please copy this down, answer the question, and then we're going to move on. All right. So in the previous example with the beachgoers, there could be a group of people who neither got sunburned or bitten by a mosquito. How do we represent that population? So A or B plus not A or B equals the total population. Right, so we're going to draw this big rectangle around the two circles. So I have neither sunburn nor mosquito bite. So it would be the complement of sunburn and the complement of mosquito bite, the intersection of the two. So I have sunburn, mosquito bite, sunburn and mosquito bite, and neither sunburn nor mosquito bite. All right. So we're going to go back through this again. I have a similar example. 40 people attending, 17 sunburned, 25 people were bitten by mosquitoes. 10 people got both. How many people were neither sunburned nor bitten by mosquitoes? So I'm going to set this up. 32 is equal to 17 plus 25. So I have 40 people. 17 plus 25 minus 10 is equal to 32. 40 people going to the party. 40 minus 32 is equal to 8. Neither sunburn nor mosquito bite is 8. Intersection is 10. Sunburn 17. Mosquito bite is 25. All right, so you see how that works. I added another dimension, another element of computation with a total population that included neither sunburn, the intersection of the complement of sunburn and mosquito bite. All right, so let's go back to our two-way table and let's go back to the pierced ears example. A table to the right shows a sampling of individuals by gender and whether each individual had a pierced ear. And so we can see how this plays out. Event A is 71 for a count. Event B is 84. So males. So A is male. B is pierced ears. So A is male, B is pierced ears. Intersection of A and B is males with piercings. Complement, intersection of the complement of A and the intersection of the complement of B would be females without piercings. And so that would be 4 here. So you have this diagram then in its entirety. Males, pierced ears, neither male nor pierced ears, and males with piercings. All right. And so you have this table, you gathered the information from the table, represented it in the diagram here, in their totals. Right, so this brings us to homework 5.2.6. So we're going to use a two-way table to create a Venn diagram after identifying the count of the values. So you're going to, event A is going to be home ownership, and B is going to be high school grad. And so you're going to use this information in similar fashion to create a Venn diagram as we did previously. And that will bring us to the end of class. Thanks very much for joining. Please complete this last homework problem. This was 5.2.6, and turn this in the appropriate location.